Hello everyone, my name is Daniel Dominguez, and today I'm going to walk you through the code I used to create the climate data analysis and additional stuff for the fertility and mapping team. So first thing I did is I downloaded this data file from the National Park Service that has all of the national park boundaries shapefiles in it. Then I created this table so I could isolate the ones that I was interested in. I'm picking Yellowstone National Park and Grand Tetons. And I read in the boundaries. And then I can use the Elevate package from the USGS to extract the DEM of the area. And I'm going to mask the DEM to my boundary. And then because we were interested in isolating slope and aspect to find new sites in Yellowstone National Park, I'm creating this slope and aspect in radians feature so that the mapping team can use it to extract site aspects. And this is what it looks like. And we're going to take a look at the elevation data to make sure it looks right. And I don't know if you've been to Yellowstone National Park, but there's a lot of valleys and mountains, so this looks about right. And this is what the DEM looks like. You can see all the spatial features that are available. And then because the mapping team also wanted to download some data from the national map, but it's kind of hard to navigate if you don't know what you're doing, I created this special polygon for them so that they could upload it to the national map and more easily navigate through the data sets for this location. And this is me just writing down or extracting the shape files so that I could provide them to the rest of the team. And then I repeated the process for Grand Teton National Park. And then I also was able to get water quality data from the USGS. We're going to take a look at one of the gauge stations located within the park. So we have the raw data reading in from Tantalus Creek. And I'm just going to use my code to make it more easier to read and for the rest of the team to be easier to read who may not be as familiar with hydrology. So we have, we have flow, the code, quality code from the USGS, what water year the reading takes place in, and the site. And this may seem really repetitive, but for students like myself who at the beginning of the summer, we're probably working with just school laptops, probably not high end, not a lot of RAM to be able to do large functions in. It's easier to go through functions one by one and not overtax your computer. And this way, more people also have more accessibility to it. So repeating all of this, and then again, writing all the data so the rest of the team can use it. And then similar for SNOTEL data, I did one site at a time, which I found on the SNOTEL station map. And I like using the SNOTEL station map because it helps give a visual of the surrounding area and you can start picturing where you're getting data from. So we're going to look at SNOTEL station 924. And as you can see, again, we have a lot of columns. We have soil moisture, air temperatures. So I'm going to go ahead and clean this up a little bit, just make it easier to work with in the future. And I use this code to do it, just renaming my columns, filtering, and then extracting year and month. for later use. This is what this looks like. So much cleaner and more easier for the rest of the team to work with again. We worked with a lot of freshmen and sophomores this year who probably have not gotten into a lot of data manipulation and data analysis. So we just want to make sure that they're able to intuitively read and understand what's going on with this data set. And then because one of our variables that we're interested in is temperature, we're going to extract all the temperatures into their own little file and summarize it. And this is what we end up when we get Tmax, max temperature in Celsius, similar for minimum, and the calculated average between those two, and the date. And yeah, this is just repeating what I just showed you. And then I repeated that for numerous sites. And then I also downloaded weather data from our NOAA to help fill in gaps. And we're going to see what that looks like. So see what Mammoth looks like. So the way that our NOAA stores their data, you get these yearly and monthly data sets for each variable, and values are the days of the measurements that we observed. So what I did for my code was I selected these elements that I'm interested in, and then because we know that every column for a day measurement starts at value, I'm selecting all of the columns, and then I want to focus this data set on just max temperatures. Then I'm going to use pivot longer to make that long scripted column, and then I'm going to group by year and summarize. I'm going to show you what that looks like. We have year, month of the observation, Tmax, and then temperature max in Celsius. And I'm going to repeat that for minimum temperature. And then I'll show you what that looks like. This is what we end up with, month, year, date, and the average temp for this site. And I'm going to repeat similar processes for precipitation. And then I'm going to sum up the precipitation that each month had. That is what it looks like, date, precipitation centimeters. And this is what it looks like. And then I'm going to do something similar with snow. Again, we get snow in centimeters. And then, so we're going to keep going. I repeated all of this for each site. And then I did a similar workflow for Grand Tetons National Park. But I'm just going to go ahead and skip into the final analysis for Yellowstone. So because I have the same columns for temperature observations for each site, I'm able to just stack them on top of each other, and it'll look like this. You got month, year, date, average, site. So we'll have different sites all stacked up on top of each other. And then we're going to summarize them for our NOAA. We're going to get year, month, the average temperatures. You're going to paste the date so that they will have a similar date column. And then we'll be able to plot it all up. And this is what we end up with. We have temperature observations for each month at each site, and you can see that fluctuations tend to be similar between one another, which is really good. And then we can see some outliers in the data. Let's see, take a closer look and see what that looks like. So this is what we all look like. So obviously we can see that historical measurements happened in a less frequency than current observations. We can see that there's way more data points for probably 1990 and moving forward. But this historical context shows us that you know, we're seeing similar measurements on a different scale though. And we're going to go ahead, move on to our next plot, and we can see what the time periods are for different observations. So we can see that there's this big gap for one of the sites. You can see that some of the sites only started again in 1990s moving forward, and kind of shows where the monitoring stations were. So we can see Green Mammoth and the East Entrance. And then we can see what we can use a bar plot, not a bar plot, an IQR plot to see what the data looks like and see how many outliers we have in each month. So as we can see, temperatures have been somewhat normal. We can see some fluctuations and some outlier data, which should be expected if we're looking all the way back to the 1800s. But overall, it looks really good. And again, the purpose of this was just to be able to create a large spatial data set that students can work with for future internships. And then we're going to do something similar with snow. Again, we can see that snow is a little more varied. And we can take a look at what that looks like. In the raw, yeah, we can see that there's some snow measurements, probably snowstorms that blew in different periods. And yeah. And we can do the same with precipitation. And we can see that precipitation is a little bit more uniform, except for this big outlier. And we'll see what that looks like by itself. And yeah, we can see that precipitation measurements are all pretty similar, except for this big data point over here. That's to be expected. Again, we have this long observation period, so one outlier in this big data set isn't too much to worry about. And then again, you can use R to be able to provide the rest of the team with this data. And then I repeated the similar plots for Grand Tetons National Parks. And yeah, that was my workflow. I hope you enjoyed this lesson.